Hi everyone. Today's concept is process and threads, which is a fifth unit under advanced behavioral modeling. So this is one of the concept of advanced behavioral modeling. So now we are learning about process and threads. So initially, what is the process? Process. What is the process? As you all know, in operating system subject, you have read in operating system subject. What is process? Process is program under execution is a process, right? So whenever in your computer, when you open any program, okay, when you are running any program or a text file or a video file or anything, when you are open any program, in background the process is running of that particular program. So that is a process. So then what is thread? What is the thread? Thread means a unit of execution of a process is a thread. This process, so whenever to execute larger program, this process divide the program into threads. That's why thread is a one unit of execution of a process. One unit of execution of a program or a process within a process, right? So let me discuss about this process and threads in this unit. As this is a UML, how we design this process and threads using UML, right? If you see this process and threads, as you all aware about it, process is a heavy weight. Why process is a heavy weight? The process is a heavy weight because for communication, this process takes more resources, whereas this thread is a lightweight process, which means it takes less resources for a communication, right? So this process is a heavyweight flow that can execute concurrently with other processes, whereas this thread will shares the memory of process. It will it will concurrently execute with along with the all other threads within the same process, right? So what is an active class? This active class contains active object. What is an active object? This active object which initiate controlled activity is an active object. Simply, active object is a client. Active object is a client. Okay, whereas the passive object, you see, if this active object is a client, whereas this passive object is a server. Okay, assume this passive object as a server, whereas the active object is a client, right? If you see this figure, so this is an active class. So how can we say this is similar to a just like a class? The only difference between the class and the active class is active class has bolded rectangle box, whereas the normal class won't it is a normal rectangle, whereas this active class is a bolded rectangle. This event manager is an active class. It contains two methods, suspending and a flush operations. So this this flow control of system are there are two types. One is a sequential system, other is a concurrent system. In sequential system, only one thing will happen at the same time, whereas in concurrent system, more than one thing will happen at the same time. There are two types of system. One is a sequential, other is a concurrent system. If you know, as I told you, what is an active class? It contains active objects. This active object which initiate the control activity. It is just like a class. This is just like a client which initiate the control activity, initiates the request. This active object is a right. So next, standard elements in this process and thread is a process stereotype and thread stereotype. So actually in this UML, there is no notation or symbol for process and thread. For that purpose, so we are making this process and thread as stereotype. As I told you, when there is no symbol for process, then we can add this process in inside the stereotype. Then it can becomes a process notation. Similarly, this angle brackets, if we write anything between this angle bracket, then becomes this process is a stereotype. Why? What is the stereotype? When there is no notation or a symbol for a particular thing, then we can add between this stereotype. Then this process now becomes a notation or a symbol for the process type. Similarly, for thread, there is no notation or a symbol in UML. That's why we have to write inside stereotypes. Then it becomes a thread symbol or a process symbol, process notation or symbol, right? So communication, generally communication between, there are two objects. One is active object, as I told you before, and passive object. What is the active object? Who would initiate the control activity? What is passive? Passive means secondary. It does not initiate the control activity. It will take request from the active object. This communication between, so this active object is a, this active class is a client. Okay, whereas the passive object or class is a server. So the communication between the client and the client, or the client and the active is a active to passive, which is a client and the server, or passive to passive, which is a server to server, or server to passive to active, which is server to client. The communication may be done in any one of the following. Right? This is about how the objects are collaborate. That is communication, right? By interacting with each other, by sending messages. So this is communication. This now, so if you see this diagram, if you see this diagram, so there are three active classes. How can we say these are active classes? It is a dark rectangle. Dark bolded rectangle is a active class, right? So here this knowledge source contains lot of knowledge. It is giving the solution to the blackboard, partial solution to the blackboard. This blackboard controller initiates the request, which initiates the request, and it will search the knowledge from this knowledge source and evaluate the results. This knowledge source will give the solutions to the blackboard. So this is the model. This is a model how we are. This knowledge source is a passive object, whereas this board controller and blackboard are active objects, which is the clients. This is the server. So this is a small model of active and passive objects. Synchronization, you know what is synchronization? So a synchronization, when multiple flow of control, if you want to execute multiple flow of control, then we have to follow synchronization. Whenever we want to do in a single time multiple tasks, then we will go for synchronization, as you all read know in Java as well. So these synchronization approaches are, there are three kinds of synchronization approaches. One is sequential, other is guarded, other is concurrent. Sequential means only one thing will take place at one time, whereas this guard, it makes the multiple flow of control using this guard operation as sequentialized. It sequentialized the multiple flow of operations using guard operation, whereas this concurrent technique is how we execute multiple flow of control at a single time. If you see this diagram, so this is a buffer is an active class. So all these are the add and remove operations. If you see this, these are the constraints, concurrent constraints, which means anything we have written in the flower bracket then becomes a constraint. So these operations are running at the same time. These are concurrent access. This buffer is an active class. These are operations. These are attribute. Okay. So now the common modeling techniques of process and threads. So in order to, so here we can model multiple flow of control using process and threads. We can model multiple flow of control using process and threads, and also we can model Inter-process communication using process and threads. For to model multiple flow of control, first of all we have to identify the concurrent access and we have to make it as an active class. Then we have to distribute the responsibilities among these active classes. Then we consider how these objects are collaborating from one to another. Then we have to pay attention to the communication between these active objects and passive object. We have to communicate using synchronous and asynchronous messaging. Synchronous messaging means there is a response or acknowledgement whenever object has a initiative request. Then if we give the response or an acknowledgement, and those kind of messaging is known as synchronous messaging. Whereas asynchronous messaging, this is only one way messaging. There is no response or acknowledgement from one object to other object. After that, we have to pay close attention to how these active objects and passive objects collaborate each other. If you see this figure, so this trading manager, these are all the active classes. This trading manager, he is doing trading with the help of this CNN news feed. So using this news channel or using this news feed, he is getting the information, and also he is getting information from two analysts. These analysts giving information by using the stock ticker, and both the analysts are helping this trading manager and giving some information information about the trading. This trading manager will take the information from alert manager. After these both analysts getting information from both the stock ticker and index watcher, they will post the information to alert manager. From then this alert manager will post the information to trading manager. In this way, this trading manager getting information from both CNS and alerting manager, and he will trade based on the knowledge he have. So now, how to model inter-process communication? So to model inter-process communication, first of all, we need active objects. So we have to consider active objects which represents either a process or a thread. We have to differentiate using some stereotype. Next, we have to model the communication by using some messages and remote procedures, right? So using synchronous and asynchronous communication. Then, so we have to specify the mechanism by using some nodes, which is a comment. So nodes is a comment. By using nodes, we have to specify the mechanism how the active and passive objects are collaborating and doing communication. So if you see this figure, this is how we model inter-process communication. Inter-process communication. Okay, if you see this figure, there is a trip planner. These are all the active classes. So this is a active class. This trip planner is a active class. That's why it is a client. This reservation agent is a passive class. So so since it is a server, it is a passive object. So this trip manager initiating the request to the reservation agent, which is a reservation server. So this reservation agent will take the information from ticketing manager and hotel agent, and he will book the ticket, and at the same time he will book the room in the hotel. And these things are done in parallelly by using this make operation. This make operation, you will gather the information and post the information to intimate the information to trip planner. So here, if you see, this reservation agent and trip planner collaborate each other to perform one task, like that is it is booking the ticket manager to the trip planner, and also it is booking the hotel room using hotel management. So if you see this, these are all the processes, not the threads. All these are processes. If you see this location is equal to, this is a tagged value. If you know the UML extensibility mechanism, there is a tagged value. Tagged name is equal to tagged value. Here the location is reservation server. Here the location is airline server. He's booking flight tickets. It is a location is hotel server. It is the, so by using these, he will doing the task parallelly and posting the intimating the information to the trip planner. That's it. Thank you.